So I won't be solving this problem here. I just had it and I just wanted to go over it because it has that concept of factors that are obviously not linear and that cannot be factored. So if you have x squared plus 1, you obviously cannot factor this into distinct linear factors or repeated linear factors. Same thing with x squared minus 5, right? You don't want to write this as x plus root 5 times x minus root 5, right? That's not really that's not what we're looking for here, right? We want those distinct linear factors such as x plus 3 times x plus 4, right? And obviously when we have those distinct linear factors, we're using those variables a, b, c, and d, right? So here for x, we would have something like a divided by x. And then when we have x squared plus 1, so the thing here is that we always want the degree in the numerator to be 1 less than the degree in the denominator. I had said that in one of my previous lessons as well. It's a really important concept when you're doing partial fraction decomposition. So usually we have those distinct linear factors. Well, if it's linear, then the degree is 1. Therefore, we end up using these variables whose degree is 0. So when we have something like x squared plus 1 that cannot be factored, right, something like that, well then we say that it must be it has to be 1 degree less than the expression we have in the denominator. Well, if this is degree 2, we must have degree 1 in the numerator, so it becomes bx plus c divided by x squared plus 1. Similarly, this one cannot be factored, right? This is your quadratic, and you can't factor this into distinct linear factors, so we would say plus, right, plus, obviously you want to use different variables. You have dx plus e all divided by x squared minus 5. This is what we're looking at, really. And obviously if you had something like, I don't know, x cubed something here with x cubed that cannot be factored into a linear factor or into a quadratic factor, then obviously instead of having bx plus c, then you would have something like bx squared plus cx plus d. Right, if you have that cubic, because the numerator has to have 1 degree less than the denominator. That's why, because we have a quadratic function here or quadratic expression here, the one in the numerator here is in the linear form, right? Bx plus c, right? Mx plus c. So that's what we're looking at. And obviously after you have this, you use the same concept. You get the common denominator, you multiply your numerator by that, right? And then you start putting values in for x to eliminate some of your variables to get your other variables, right? To get the values of other variables, and then obviously take various values in for x and substitute them back into the expression to get your system of equations, and then solve for the rest of your variables. So I don't want to go over this specific problem. You get the idea here. I just was giving an overview of this because you may see something that is not necessarily a linear factor all the time, right? You may see something that is a cubic factor or a quadratic factor that cannot be factored, and then you're not using b here, you're using bx plus c because there's a quadratic factor down here, right? The numerator would have to have a degree that's 1 less than the denominator, but here I still have calculated the value, so if you want to check your work, you can. A should be equal to 2, b is equal to negative 8 over 3, c is equal to positive 2, d is equal to 8 over 3, and then e is equal to positive 1. So when you're writing your final answer, you would have something like 2 divided by x, right, plus, well, you have negative 8 over 3, right, that's the value of b, x, plus c, your c was 2, so you have plus 2, divided by, you have x squared plus 1, right, so we just write that as x squared plus 1. And then we would have plus dx, well, d is 8 over 3, so we would have 8 over 3 x, e was 1, so 8 over 3x plus 1 divided by x squared minus 5. So this over here would be your final answer to that problem. So thanks for watching.